what's the difference between a sequence and a series?
A series have like plus and
Very
minus, does it?
Yeah, that's correct. You'd be adding or subtracting, and a sequence, you just have commas between terms. Okay, very good. So we're just looking at sequences yet. Okay. In the log tables, in the formulas book, there are some formulas given in the log tables in the sequence and series section. There's a series given here. It says it's -2, 3, 8, 13. We're to use that series, and we're told it's an arithmetic series. Now, arithmetic is another word for linear, okay? So this is a linear series, and when you think linear, straight away, I would like you to be thinking of a straight line. So when you think of linear, you think the series looks like an plus b. That's what I want going on in your head. In the log tables, it does present it differently. It presents it like this. Okay, which is kind of the same, but it's different. And unfortunately for this, the letter A in this term n series is slightly different as well. The letter A here stands for the first term, and the letter D stands for the common difference. Maybe write this a bit closer where you can see it. So D stands for the common difference. So we could write each term or a general expression for the term in terms of the first term and how many common differences have been added on. That's what that formula is. Or we could express it in terms of this, I'm putting in yellow here, it's like y equals mx plus c, in terms of kind of the c, which is sort of the zero term, and the slope, which is kind of to do with the common difference as well. So how would you go about this question here? -2, 3, 8, 13. If you got this in a test, the first thing to do would be to note how is it changing. And you might see as you go from one term to another, each time we're always adding on 5. Okay? So the next term in this series is going to be?
+5, and that's 18.
Very good. And it goes on like that. The method that we use to find the general expression for this that I've mentioned already, I suppose, you could just go back one. Now, this term doesn't exist, but if there was a zero term, what would it be?
-7.
Very good. It'd be -7. So according to our formula that looks like this, an plus b, where b is like the kind of the y-intercept, the zero term, straight away you could say, and a would be your slope, straight away you could say that term n in this series, the general expression for this is 5 times n minus 7. So that's using the methods that we have already. Okay. You could also come to that, I suppose, using inputs and outputs. So another method that we have to do this already, we know it follows the pattern an plus b, and we know that a is equal to the common difference. So what do we call the common difference? The first difference is what we probably call it here. The first difference is what we call it. That a is the first difference. So we could look at this straight away and say a is equal to 5. And then you could use inputs, outputs either. So you could say, I know that when I, term 1 for instance, when I sub in when I sub in 1, the output is -2. So if I sub that into the series an plus b, I get that 5 times n plus b, the output is, where n is 1, 5 times 1 plus b is equal to -2. So straight away you'd see quick enough that b is equal to -7. So you could, this is a second approach you could do. Today I'm going to show you how to use this formula here. Term n is equal to a plus n minus 1 times d. look, I'm not a huge fan of this formula, but look, it's very common on the course. Some teachers go straight into teaching this. But just to explain how this one would work, you'd look at your series here straight away and you say, in my series A, now, by the way, A means this time means the first term is -2. You'd say D in this, which is the common difference, is 3. Therefore, you'd say term N must be -2 plus N minus 1 times 3. Multiply that out and you get -2 plus 3N minus 3. Oh, sorry, my common difference is not 3. Sorry, common difference is 5. Sorry, I don't know what I'm talking nonsense here. This is -2 plus 5N minus 5, which is equal to, if you wish, 5N minus 7. Now, just having a glance at those, look, which of those 3 methods that I've shown you there do you think, which ones do you like? Do they all make sense?
The first one.
First one, it's okay, yeah. Could I ask you just, I'm not going to do this whole question here, would you work out, everyone take out your pen and paper, copy, whatever, would you work out the answer just to term 20 for me here? What do you think term 20 is? Okay. Shout out an answer when you have it. What's term 20?
93.
93. Do we all get 93? So what you hope you're doing is into the formula, which is 5n minus 7. You're saying 20, 5 times 20 minus 7. 5 20s are 80. 80 minus 7 is, am I saying that right? So yeah, 100 minus 7 is 93. 5 is 100. Okay. Okay, so that's term difference. Look, there's nothing totally new already this, because we've been doing in patterns, we've done a good bit, I suppose, on arithmetic, which is another word for linear. Okay. Okay, example 2. This is a little bit different. It's asking me to find how many terms in the sequence. Another way of understanding this question is really what it's asking. It's kind of asking which term equals -251. That's what the question is asking me. Okay. So we'd look at the pattern first and see what type it is. It's probably going to be arithmetic given the type of thing. So I see going from one step to the next. What's going on this time? We seem to be adding 4 each time. So very quickly I could figure out, so I'm going to use my own method on this. You could use the term n formula that I've shown you a second ago. If there was a 0 term, there isn't, but if there was a 0 term, it would look, oh, sorry, I'm saying this wrong. We're subtracting 4 each time, sorry. If there was a 0 term, it would be equal to 5. Okay, so I could quickly enough, just by observation, look at this and say that term n must be -4 times n plus 5. So that's the formula first. Okay, it's asking me which term is equal to -251. How would I do that?
Make it equal -251.
Very good. So -4n plus 5 is equal to -251. I'm going to take 5 from both sides. So -4n is equal to -256. So n is equal to, you can make them, if that's true, obviously positive 4n is positive that. So n must be equal to 256 divided by 4 which is equal to, calculator here, 64. So what I'm saying is term 64 is equal to negative 251, or the question was asked was how many terms. There's 64 terms in that. How does that seem?
Good. Grand.
Grand. Okay, I'm going to just keep going. I think in this, there's a few, what I'd like to do, if it's okay with you today, could I just work through these three things and I'll let you go then. Let's check my stopwatch. See, is it still working here? 14 minutes. I can do this in 6 minutes. Okay. So this is slightly different. There's an arithmetic series. So I know starting off, I know it's linear. Okay. I know that term 4 is equal to 6. I know that 3 times term 2 is equal to term 10. And we're asked to find the values of A and D. Okay, so this time, look, I am forced into using the term n formula. So A, again, just to remind you, A means the common difference or first difference. So A means the first term, term 1. Okay, and D is the common difference or first difference. So this time I will use the formula. Okay, so the formula says that the term n is equal to the first term plus n minus 1 times d, that I've added on the common difference 1 less than the term number. So the first term you've only added on, the second term you've added on 1 extra common difference, and the third term 2 common differences. So that's what this formula is about. Bear with me now. So this is my formula. So term 4 must be, I don't know what A is, but it's A plus 4 minus 1 times D, because I know that n is 4. And I know that that is equal to 6. So just tidying that up, it tells me A plus 3 times D is equal to 6. So that's the first equation that I can get out of this. It then tells me that 3 times term 2, so that'd be 3 times A plus 2 minus 1 times D, must be equal to term 10, which is A plus 10 minus 1 times D. So I'm just going to neaten this up. So that'll be 3 times A, 2 minus 1 is 1, so A plus D is equal to A, I have 9 here, plus 9D. So that's 3A plus 3D is equal to A plus 9D. Taking A from both sides and taking 3D from both sides, I see that 2A, if you wish, is equal to 6D. And dividing across by 2, I see that A is equal to 3D. So I have 2 equations to solve. These are simultaneous equations. So I'm going to sub this value for A. I think that would be the easiest thing. I'm going to sub that in here, in for A. So it would tell me then that 3D plus 3D is equal to 6. So obviously 6D is equal to 6. So obviously D is equal to 1. That's the first part of the answer done. And then obviously A is equal to 3 times D, which is 3 times 1. So A is equal to 3. I might write out what my formula is. So the formula is that term n is equal to A, which I know to be 3, plus n minus 1 times D, which is 1. So that would be equal to 3 plus n minus 1, which is equal to 2 plus n. So that's what my formula for is for term n. It's 2 plus n. So the first term is n is equal to 1. So the terms, the sequence then, when I put in 1, I'm just getting 2 plus 1, which is 3. The second term is 2 plus 2, which is 4. You can see it's 1 times n, so it's just counting up on 1. So it's 3, 4, 5, 6, etc. That's the the terms in the sequence. Is that what's written in the book there as well?
Yeah.
So okay, so that's what. Okay, so a little bit similar. These are 3 consecutive terms in an arithmetic series. It doesn't tell me which terms they are, but someplace in the middle of the series, there's a term that's p plus 2, and then there's a term that's 2p plus 3, and then there's a term that's 5p minus 2, and then the series continues. Now, since these are consecutive, can anyone tell me anything that happens that I go from one term to the next? So I need you to think about this. If these are consecutive, what does that tell me about as I move from p plus 2 to 2p plus 3, and move from 2p plus 3 to 5p minus 2? I need someone to tell me, is there anything?
You're continuously adding 1 to it.
I'm continuously, well, I don't know that it's 1, but I am continuously adding the same thing. I'm going to call the same thing I'm going to call it D, the common difference. What I know is, as I move from one to the other, it's adding the common difference. Or, to put it another way, that this one is bigger than this one by D. Or, put it another way, if I subtract p plus 2 from 2p plus 3, I'd be left with the common difference. So this is I'm going to use this idea to do this question. So this is an important idea, that if I have one term, I'm going to call it term n plus 1, and I take away the term before it, I'm going to call that term n. Okay. So I'm taking away the smaller term from the bigger term, the later term from the term before it from the later term. The answer to that is the common difference. Okay. So the common difference is the difference between one term and the next. Does that make sense? What happens? Wouldn't it be true that 2p plus 3 subtract p plus 2? Wouldn't it be true that that must be equal to the common difference? And must it also be true that 5p minus 2, sorry, just put that in brackets, take away the term before it, 2p plus 3. Mustn't that be equal to the common difference also? So if both of these are equal to the common difference, well then they must equal to each other. So this is my equation. So I have 2p plus 3 minus p plus 2 must be equal to 5p minus 2 take away 2p plus 3. Now this is an equation, there's only p's in it, so we've sort of solved our problem. Just be careful with your signs here. So I have 2p plus 3, I'm subtracting p and subtracting 2. Be careful with the signs. I have 5p minus 2, I'm subtracting 2p and subtracting 3. Just tidying up the left hand side here, 2p take p is p, plus 3 minus 2 is plus 1. On this side I have 5p take 2p, which is 3p. And negative 2, negative 3, which is negative 5. What I might do is maybe make the right hand side the p side if you wish. I'm going to take p from both sides and add 5 to both sides. So that would be, I get 6 is equal, I was taking p from both sides. So I end up with 6 is equal to 2p, and I half both sides, so p is equal to 3.